Hello everyone, we will solve this today's LeetCode problem, and this is LeetCode medium 1. So this is a cousins in binary tree 2. We have given the root of a binary tree, replace the value of each node in the tree with the sum of all its cousin values. So we have given two nodes of a binary tree which are cousins, and if they have the same depth with different parents, then we tell these two nodes are the cousins, right? And if we return the root of the modified tree, we need to return the root of the modified tree after the changes of every node's values. So for the first example, if we see here that the condition which is given here in this, we have also I've already solved this question. So basically, after that we will solve this implementation problem. So basically, we need to just change for each of the every node. After that, each node to its sum of the values of the summation of its siblings, right? And here's what the siblings means. The siblings means is that we need to replace the value of node with the value with the summation value of other nodes whose parents are different, right? Whose parents are different, right? That's the question conclusion of this question which is given, right? So if we want to see that how this goes, so basically if you see the first example, right? If you see the first example in this case, so this 5 has no parent, right? So it's no siblings also, its value 0. Its 5 children are 4 and 9, but it's 4 and 9, there are no siblings of 4 and 9 because there is no other parents whose children are there, so its value is also replaced with 0. But now if you see for 1, 10 and 7, fourth children is 1 and 10. 1 and 10 have the same parent, but 7 is of different parents, so this 1 and 10 value will replace from 7, right? And for 7 value, the parent which is different for 1 and 10 is 4, and that's the summation of the value is 11, right? So this is how we change the value of the node with the summation value, right? That's how we will change it. So if you see one thing, that here we need to check in level order traversal, in level order, right? And whenever we see level order, we can think of level order traversal, we can think of level order traversal, right? And how this works, same queue data structure, right? Now the problem is that how we will know that at which point whose parent is different and whose summation is to take, and what could happen, right? Okay, one thing is to note that at each level, at each level, one thing is to sure, I'm sure about that, that we need to take summation, we need to take summation. How we will take, that's the later point on. I am sure that we need to take summation, then we can only change of it, right? Now if you observe one thing, if I see you diagram in this case, let's make it as a 6, right? So this is a bigger diagram, let's visualize this. So for 1 and 10, if you at the third level, at the first, second and third, at the third level, 1, 10, 4 and 7, if you take the summation of all, this will be 11 plus 4, 15 plus 21 plus 22, right? So if you want to find the siblings summation of node, then you can simply what do, you take summation of 1 and 10 and subtract it from the whole summation of at that position level. That will give you definitely for other siblings summation. What I mean is if you take second level, right? At second level the elements are is 1, 10, 7, right? 1, 10 and 7 and 4 and 7, okay, these are 4 and 7. You will observe this, right? Don't see this, see here, 1, 10 and 4, 7. If I take summation of this, it will be 22, right? And if I want to find the summation of siblings for 1 and 10, so that would be total summation of this, which is 11. So 1 will replace from 22 minus 11, 10 will also replace from 22 minus 11, and that will be equals to 10. Sorry, that will be equals to 11, right? So one thing is to clear that I need to take summation at each level, right? I need to take summation at each level, right? I need to take summation at each level, whole summation of whole node, of all the nodes, of all the nodes, right? Second thing, that I need to take summation of the nodes of each parent, right? To subtract it and change the value, then I will change it. I will simply change it, right? Okay, these things are clear, right? But how we will, the main problem is, so first thing is clear that we will use level order traversal. For that we will use q data structure, right? Then I am clear that I need to take summation at each level. Then I'm clear that I need to take summation of the children's nodes of each parent. So these three things are clear. Now we need to make a flow that how will this work, right? So let's discuss it, right? Now, when in the level of traversal, what we do, we simply insert in queue, right? So when you try to insert this, the first thing, which is 5, so this is 5. Now when you go to 4, this 5 children is 4 and 9, right? Now when you go to 4 and 9, 4 children is 1, 10, 9 children is 4 and 7, right? These are the things, and this goes on and on, right? This goes on and on, right? Simply understood. Now when you think, what we need to do, when you go to 5, it has no parents, no siblings, value is 0, right? Value is 0. When you move to 4 and 9, it has the same parent but no other siblings, its value is also changed to 0. But when you go to 1, 10, 4, and 7, the 110 is of same parent, 4 or 7 is a different parent. They have siblings, they all four have siblings. Now what we need to do, when we level or traversal for this 1, 10, and 4 and 7, what we do, we will simply take summation of all the elements present at this level, at the third level. This is the first level, this is the first, second, and this is the third, right? This is the third level, right? So at the third level, we need to take summation, right? We need to take whole summation, whole summation, whole sum, which will be equals to 22, right? For 110, I need to take separately summation, right? I need to take summation of the children of each parent. So 110 summation we need to take. So 110 summation, 1 plus 10 summation will be 11. And what I will do, I will just minus it and change the value. So 22 minus 10 will be 10, 11, sorry. Again, don't see example 1, this, see this 1 4 1 10 4 7, right? Example is changed right now, right? So this is 11, right? Same goes for 10 also, this will be also 11. Now when we go to 4 7, we need to take separate separation summation. Why? Because it will, it is of different parent, right? This is the parent, its parent is 9, right? So 4 7 is 11, but summation is 22. Again it will be minus, so that will be 11, then again 11, right? So this is how we change this. Now the problem is, if you use only one queue, if you use only one queue, then this node value is changed. But when you move to its other parents, like 4 3 2 1, 4 3 2 1 5 5, that's its value is already changed. So how will you pick up this, how will you know this, right? So there we need to use a different queue data structure, another queue for that, right? Another queue, so that, so that I can simply change the value, change the value of the nodes, of the nodes. So basically what I'm doing, I will use two BFS, right? I will use two, I will run run two times BFS internally, internally, not whole, but I will use I will run two times the same thing, the same size problem, same size internally, right? So that will help me for that, right? So if I start iterating from here, so why I have taken two size, because one queue will help me to take summation at each level, another queue will help me to take summation of each parent individual and change the value of the current node. That's what it helped me, right? Right. So fun queue is help me to take summation of whole, and second will help me to take summation of individual parents and store its value, right? So let's implement it, you will better understand. So let's think, let's we will take this queue data structure, and this will be the root part, tree node, and this is queue, right? The same thing is we need to take two queue, so this is q1 and this is q2, right? Now we will push this root in both of them, because that would be, we are taking two, we are taking two queues to implement it this. So this is q1 and q2. Now we will iterate in q1 just as simple as level or traversal. Now the first thing is that I need to take summation of each node, right? I need to take summation of each level. So for at each level, what will be the size of level till now? That's what, and that's how we find the level. At each level the number of nodes is 11047 and this is 49, right? So what we will do, we will check for each of the levels how many nodes are there in each level, right? So this the first level has 4, second level there are 2 nodes 49, the third level there are 4 nodes, like that, right? So we will move in the size of problem. Now this is the node and this is q1, we will remove that. Now we need to take summation at each level, right? So this will be the summation of each level node value, right? Also we need to insert the values in node. So what we will do, we will insert the value in our nodes. So we need to insert in both of the nodes, right? We need to insert in both of the queue data structure for the same node. So node left, and this will be the node right. Same goes for node right. Right. Now what I've done, I have calculated the summation value at this while loop, right? Now I got the summation, the level sum. Let's take name as a level sum, right? It's a bit confusing. Let's take level sum. So I got summation value of all the nodes at a particular level, right? Now I need to change the value of the particular root node. So again what I will do, I will iterate in which node, this q2. Why? Because we have already popped up all the nodes which was in q1. That's where the need of q2, right? That's where the need of q2. So the same will happen, will same do the same process here, q2 dot front, and this will be popped up. This will be q2, not q1, right? Now why what we need to do now, we need to take the all the summation of the childrens of the same parent, right? So its parent is value is node left, so its summation would be stored. Let's take its summation value which is 0, and this will store the summation of each children's of a same parent value. So left value, and same will be repeated for right. So this is the right and this is right. Now what we need to do, we need to change the node value, right? So what we will do, we will, if this node left exists, we will change this value with, we got summation of all the children at this rest part, and the summation of level sum of all the nodes here in the level sum. So we will just minus this level sum till rest, right? And same goes for right values, which is will be the right, and this is the right value which is the level sum minus raise. So this is how we just change the value of each and every node in the second loop. So the first loop is used for summation of each level, and the second used for the changes of values. Now this value is changed, and that's how we will just return the root value, because all the values have changed, and this queue will be anytime it will be empty, right? So this is how we solve this problem. Let's try to run this, and we will see that we have if we have not making any compilation error, this will pass. Okay, we have found some errors. uh, This is undefinable, a node 2. Okay, something is wrong, while size minus minus. Okay, one thing is to clear that this size value we have initialized here, that is makes 0 when we run this loop, right? So we need to just maintain a different value which is same as size and iterate in that, right? And this will be work. Okay, some error. uh let's see this, what's the error. So what's the error in this? So we have found q1 dot size for the current one, and we have initialized this size. We are reducing it, and this will be q1 dot front. We are storing it in level sum. Then we are storing in node left values in q1 and q2 both. Then we are iterating in the same value again to find the values in the node right values, and we are changing it. It seems to be correct, but it is giving error. This is going negative, which should not be there. Okay, one thing is to clear that this root ka value should be 0. One thing is to clear, right? Now, the second thing, the label sum of node value is, oh, okay. One thing we have missed, that we are taking the summation of each label for the children's value. What I mean, that if you see here in this case, when we move to this 5, its children's summation would be there, right? This label sum would not be here. It should be here. It should be here. This node left value, because we know the parent, we don't know the about children's, and we need to label sum at each for each children, right? We need to take a label sum for each children. So this will be the right. So because we are moving from parents, right? We have changed the root value, then we go to its parents, we take the children's label sum at each step, and we are changing its children's value, not its parents value, right? At that time. So now this should work. Yeah, let's submit it. We have passed all the test cases. So we have done a two while loop here, right? We have done a two while loop in this. It means we are running for each and every node two times, right? So the, if you see, talk about the time complexity, that would be the O of 2 and 2 times of n, because we are iterating for each and every node two times in the Q data structure. And the space complexity would be again O of 2 n, right? Because we are taking two Q data structure. It just like two using two BFS, right? So